Hi, how are you doing? Today we're going to be looking at internal and external angles of a polygon. But let's break it up into two things, okay? So let's first look at the internal angles of a polygon, alright? The internal angles of a poly. Now, I want to get to the formula, but I want to get to the formula by explaining it, okay? So let's quickly take a look at this. So the first thing that I'm going to do, let's draw a quadrilateral, any quadrilateral, then I can break up this quadrilateral before I do the next one into two triangles. That's 180 and that's 180. Alright, let's draw a pentagon. 1, 2, 3, 4, 5. It's not regular, but it's okay. I can break this up into 1, 2, 3 triangles. 180, 180, 180. Okay, sum of the angles in a triangle is 180 degrees. So let's just extrapolate to a hexagon. 1, 2, 3, 4, 5, 6. Okay, and again, now with a hexagon, I can do 1, 2, 3, 180, 180, 180, 180. Okay, so this is what we saw. We draw it out, and we see we can break them up to triangles. Now look at the pattern here: 4 sides, 2 triangles; 5 sides, 3 triangles; 6 sides, 4 triangles. So each time there's 2 triangles less than the number of sides. So this is where we get our formula from. The interior angles of a poly, or the sum of the interior angles, all of them together, is 180, because they're each 180, times the number of triangles. The number of triangles is the number of sides minus 2. Okay? So 180 times n minus 2. So if I had a pentagon, it would be 180 times 5 minus 2, 180 times 3, a hexagon, 180 times 6 minus 2, 180 times 4, etc., etc. Any polygon, okay, any closed shape with straight sides. Alright, so that's the internal angles. The external angles of any polygon always add up to 360 degrees. 360 degrees. Now, it's a little bit confusing because people forget, well, people get confused about what the external angle is. This whole thing is not what I'm referring to as the external angle. Okay? The external angle is if I had to extend each side. So if I had to take this side and extend it, right? That's my external angle. But I've extended it there, so I'm going to have to extend this side there. That's my external. I have to extend that side there. That's my external. That side there, there, and then this side there, like that. It kind of looks like a Catherine wheel, you know, those fireworks that spin round and round and round. Okay, so this is what I'm talking about, an external angle. If I had to extend this side there, then this one would have to go there, and that one there, and that one there, etc. So it would go the other way. All right. Now these added together add up to 360. And if you think about the reasoning for this, every time I go around the corner, I have to turn a corner. So I have to turn a corner that many degrees, and I have to turn a corner that many degrees, and I have to turn a corner, turn a corner, turn a corner, until I get back to facing the same way. So I'm doing, from starting here, I'm turning a corner, 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 and I get back to facing the same way. I've turned 360 degrees. Alrighty. Okay, so that's the external angles equal 360, the internal angles equals 180. Okay, so let's use the internal angles. You could use the external angles in this question, but it's actually just as easy to use the internals. There's a very easy way, a very nice way of going from external to internal, because if you know the external angles of a regular, you could just subtract 180 from it to get the internal. Okay, don't worry, we'll look at that when you get to regular polygons. So let's look at this example. Find x, so, e.g., and I've got a pentagon, so I've got a weird looking pentagon that almost it has a right angle in it, and it does this, okay? Alrighty, so I've got, this is x, and 85, 134, 94, and I've got that symbol there which means right angle. Okay, so firstly I need to find out what do these all add up to. Now it's not a quadrilateral, it's not a 4-sided, it's a 5-sided. So I don't want to have to bother learning that a 5-sided pentagon has internal angles of 540 degrees. I know that because I've been teaching this for a while, okay, so I've just learned it by repetition. But you don't have to learn that. What you do have to learn is you have to learn the formula. Okay, you have to learn how to work it out, so that you don't have to learn pentagon, hexagon, heptagon, octagon, nonagon, decagon, whatever gon. Okay. Alright, so let's look at the sum of the internal angles equals 180 times by n minus 2, 5 minus 2. So this is 180 times by 3, which is 540 degrees. Okay, so that's what they all add up to. Now I've got that. So now I can make the statement. Okay, so I've got x equals 540 degrees minus 85 minus 134 minus 90 minus 94. 90 is this one. All right. Why can I say that? Okay, the sum of internal angles of a pent equals 540 degrees. That's my reason. That's why I can write this down. Don't take it for granted that because I'm writing it down it must be obvious that I know that, okay? The point of this is understand that you have to give the reason for this, okay? Plug this into your calculator, or if you've got time, do it by hand, and you get x equals 137 degrees. I worked this out before because I don't trust myself up here. Okay, so x equals 137 degrees. Now, stop, okay? And you have to say to yourself, all right, now this picture's not drawn, it's not drawn to scale, which means that the angles on the right sides. But it is drawn in proportion, kind of. Now if you look at this, this is less than 90, so that could be 85. That's slightly bigger than 90, that's 94. This is an obtuse angle, so that's 134. So this has to be an obtuse angle, okay? And so you have to say to yourself, is my size the right size? If I got an acute angle, meaning less than 90, and I look at my picture, oh, it's not an acute angle there, I must have made a mistake. Maybe I left off one of the angles, okay? Maybe I did the angle twice or something like that, okay? Always take your answer and double check it against what your picture is. Even though your picture is not drawn to scale, it'll still be in proportion. So you can estimate and by looking at it. Okay, alrighty. Anyway, that was a little bit long-winded. Remember, I'm here for you.